All right, so let's start. So your mic is spoiled, I see. No problem. Usually we communicate with each other via chat anyway. Yeah, most of the time we do that. Right. So, another student here. Today we are continuing from where we left off last lesson. Okay, we are actually doing the topic on chemical changes for Sec 2. You should have gotten your textbook by now, I think. Yeah, shouldn't be too late lah. So you should have the textbook already. And you can see that whatever I've gone through with you for the past few weeks are all found inside your textbook. Of course, I added some extra things. Okay, that should be quite useful for you as well. Okay, let me finish taking attendance. Let's see. Okay. 1, 2, 3, 4, 5. Right. Right. So last lesson, what did we cover? We actually covered the section on acids. So this is actually a concept map. So we talk about acids, right? We have not done indicators yet. We have done acid. Acid react with metals to give you salt and hydrogen gas. This you are already familiar. Then acids react with carbonates to produce a salt, then carbon dioxide gas and water. So last week, we actually wrote a lot of word equation. Then lastly, acids react with alkalis. Okay, they undergo this reaction called neutralization. Okay, and neutralization, the products will be salt and water. So if you recall, this is actually what we have covered for last lesson. Today, we are going to talk about alkalis as well as indicator. Now, alkalis are found in our daily lives. Okay, so you need to know how to describe characteristic properties of alkalis in reaction with acids. Write down word equation for the reaction of alkalis with acids. State the uses of commonly used alkalis. Okay, so you can see what we have in our daily life. Cleaning reagents like bleach, detergent, all right? Bitter gourd. Yep, bitter gourd is actually edible. It contains alkali. That's why it's very bitter. How many of you likes to eat bitter gourd? I like to. I actually enjoy eating bitter gourd, no? So I'll stir fry with egg. Yeah. Oh, Andrea, you like it? Wonderful. Yeah, it's actually good. Once a while, we take some alkali into our system, it will be good. Wonderful. So I found somebody who likes bitter gourd also. Now, most of the time, the bitter gourd that we eat commonly found in Yong Tau Hu, right? Right now, you have the bitter gourd and then there's the fish cake on the inside. Yeah. So some people likes to stir fry. Okay. After stir frying, it's not that bitter. How about you try lah? It's actually quite nice. Okay. You wouldn't. Okay. Now, Dove soap. Okay. Not just Dove. Many different types of soap that we have. They are also alkaline in nature. Right. So you will see or you will hear also me mentioning alkalis and then alkaline, right? So what's the difference? Maybe I have to tell you in case you get a little bit confused. Now, when I talk about acids, acids are acidic. Okay? Alkalis is another group of substances. They are alkaline in nature. All right, you might want to write this down. It is useful to know this. Acids are acidic. Alkalis are alkaline. So sometimes you hear people saying alkalis. It's fine, doesn't matter. Okay, the pronunciation is not being tested. This is not like English where they test you on oral examination. No. So alkalis or alkalis, they are fine. Okay, but take note, they are alkaline in nature. So the spelling matters also. Okay, so we also talked about the pH. For acids, pH will be less than 7. Alkalis, pH is more than 7. When pH is equal to 7, we call it neutral. neither acidic nor alkaline. Okay, they are neutral. So this is about pH. Later on, we will explore pH and the indicators. Okay, antacid. When you have indigestion, when you have gastric pain, you usually will take some medication and it contains alkalis also. Characteristics. Oh, sorry, let me change that. This is not acid. This should be alkali. I hope your notes show the correct words. Okay. Okay, back to this. All alkalis have the following properties. They have bitter taste. I mentioned to you last week, I think, if you try to taste a little bit of the facial wash, when you're washing your face, try to taste a little bit. Don't swallow it. Just taste it. You can actually taste the bitterness. Okay, all soaps, all detergent, bitter gourd. Some cucumbers are also bitter. When you test with litmus paper, it can turn the red litmus blue. Okay, go and try it. I have tried all these with the students. Now, they have slippery or soapy feel. Okay, they can conduct electricity, right? So why is it that they can conduct electricity? Because they can ionize. They can actually form ions when dissolved in water. They are corrosive also, which is why when you use detergent to wash the toilet, especially the toilet detergent, they are a lot stronger, okay? And these can actually cause your skin to be burned, okay, to peel off, and you can also get very dry skin. Turn red litmus paper blue. As you can see in this diagram, it's not very clear, but that's fine. Okay. Alkalis also react with acids in a neutralization reaction to produce salt and water. This is the reaction that we learned last week as well. Okay, I know that some of you are copying the notes. It's okay. I will wait for a while. Right, I'll move on. Now, reaction of alkalis with the acid. We know that this is the equation we have learned last week also. Acid plus alkali gives you salt and water. The salt is not actually the table salt that you are consuming at home or outside when you buy food. Whatever food that is savory contains table salt, right? This is not the same as table salt. This is actually the salt from the chemical reaction. It's a generic term, a very general term. For example, this particular substance here, calcium chloride, is actually the salt that we are talking about. And remember, the salt actually can be named according to the reagents added in. Okay, you have the acid part and you have the metal part. So this is the metal part, which gives you calcium. Okay, and then the hydrochloric acid will provide this chloride part. How to remember? Always recall, hydrochloric acid is known as hydrogen chloride. So it is the chloride that forms the chloride over here. Okay, Sheena is here. So over here, the ingredients are for the toothpaste. If you don't believe, you can go and try it. You can go and try it once more. Okay, try to taste some of the toothpaste. If you're very careful with the tasting, you can taste the bitterness. Otherwise, it is actually very cooling. There's a lot of the mint effect. Okay, there's if you look here, this is actually the alkali, sodium hydroxide, inside our toothpaste. Why is it that it's good to have some form of alkali inside the toothpaste? The food that we eat, right? The food that we eat actually cause a lot of acid to form on our teeth. So when you brush your teeth, you need to put some toothpaste so that you neutralize the acid. Otherwise, your teeth can decay very easily. Right, Sheena, I got it. Yeah, your internet is very bad today, huh? You may just Disconnect. No problem. If you are disconnected, you just connect back again, can? Yeah. Okay. So, yeah, these are questions that you can start thinking about. Now, you have not learned what is a base. So maybe I quickly cover with you instead of base. Now, if I were to draw a circle to represent all the things that are classified as base, there's only a small group of them that will be known as the alkali. Can? So what is the meaning here? Okay. Alkalis are also known as bases, but they are soluble bases. Soluble bases means they dissolve in water. The rest of them here, okay, will be called the insoluble bases. All right, so the base is the whole group, right? And then alkali is a subset of it, a small part of it. Because they are soluble in water, they are named as alkali. Okay, so why is it that the manufacturer use an alkali instead of a base? Is because it's soluble. Okay, only when it's soluble, it can react well. Okay, it can react with the acid well. It can remove the acid better. Okay, so why use alkali instead of acid? Because our teeth already has got a lot of acid from the food that is being that we have consumed. For example, if you drink a lot of Coke, remember we talked about this last week also. There's actually a lot of acids. Okay, so we want to neutralize all that. You should be using alkali. If you use acid to clean your teeth, this is going to corrode your teeth even more. So you are just accelerating, making the corrosion faster. Okay, so alkali is used to neutralize the acid that is found in our mouth, around our teeth, surrounding our teeth. Okay, so that's about alkali. pH scale. Okay, pH scale, if you are familiar, I told you last week, pH is actually known as the power of hydrogen. It tells us how acidic or alkaline a solution is in water. So this is a table, or sorry, this is actually a chart to show you the different types of acids and alkalis, then how acidic they are or how alkaline they are. So the smaller the number, the more acidic a substance is. Okay, so the more acidic the substance is, the smaller the number. Then on the opposite side, the greater the pH number or value, okay, the more alkaline the substance is. So if you take a look, okay, stomach acid. Stomach acid is actually hydrochloric acid. Okay, lemon is citric acid. If you want to go and find out all the names of all the different acids inside this food, you also can. Okay, but in general, what you need to know will be hydrochloric acid found in stomach acid. Then lemon is a weaker acid, is called citric acid. Now, even milk is not totally neutral. Okay, it's slightly acidic. Okay, slightly acidic. Pure water is definitely pH 7. Take note also, some tap water is not that pure. Okay, we have tested water from different parts of the school. And I realized that the water from the science lab, right, tend to be a little bit more acidic. Yeah. And then we also tested water from the pond, water from the drain. Okay. We realized that the pH value differs. Eggs are slightly alkaline. Okay. Then you go into baking soda, then soap, then ammonia, bleach, oven cleaner. So remember I told you, right, all the cleaners, all the detergent, generally they are all alkaline in nature. Okay. And then they are quite corrosive. So stated here again, pH less than 7 means stronger acid. pH greater than 7, the larger it becomes, it's a stronger alkali. So when you go on to A levels, you may even start to learn how to derive the power of hydrogen.